Hey, and welcome back to Troubleshooting Pandas. We're in a new chapter today to talk about export errors and presentation problems. Let's talk about keeping the right data and formatting it into Excel sheets. So why is this important? As a data scientist, a lot of times your function is to provide business intelligence, and data crunching functions to the rest of the organization aren't data scientists. They do not know how to use Pandas. Most likely, other people use Excel. Let's talk about how we can keep the right data from our Jupyter notebooks and export it into Excel sheets so the rest of the company can enjoy our good work. In In8, we again begin by importing Pandas as PD and NumPy as NP. The first and easiest way to create a new Excel spreadsheet is to call the function toExcel. Here in In8, the example is very simple. We create a new data frame that has two rows. The first row reads XY, and the second row reads IJ. The index is row 1 and row 2, and the columns is column 1 and column 2. Very simple. We can then call toExcel, feeding in one string that represents the file name that we want to write to, and because we have used the function toExcel, we know that it's going to write it out in an Excel format. Let's check our work. In In9, we are using pd.readExcel, and we read output.xlsx, which is what we just wrote, and we specify that we want to read all sheets by feeding in the keyword argument sheet name and setting it to none. As we can see in Out9, we receive an ordered dictionary that contains sheet 1, and sheet 1 has the values we need. Column 1, column 2, row 1 and row 2, and XYIJ as our values. So that's Out9. But what if you have some sheet naming conventions? Sometimes in my Excel sheets, I like to label the sheets containing raw data as raw, the filtered data as filtered, the cleaned data as cleaned, and then the final outputs as outputs. The reason why I do this is because I want to preserve the transformations and raw data that I've created. And so to follow this custom, we can do something similar. In In10, this example is exactly the same as our In8 example, but now we specify the sheet name. In the sheet name, we've put in a custom string. Here I'm using sheet_custom. And again, if we go to In11, we can check our work. By reading the Excel file outputs.xlsx again, and reading in all the sheets, we can see now that we have an ordered dictionary of a sheet custom with the correct data. And if we compare and contrast this example with Out9, we can see that by default, Pandas creates a sheet 1, but we've managed to customize that sheet's name. The other thing we can do is we can create an Excel writer. So in In14, I'm using the Pandas Context Manager keyword with, and feeding in the Context Manager Excel writer. I create an Excel writer by calling pandas.excelWriter, specifying the file name as a string, and I'm calling this context writer. What this means is Excel writer would open new context with the outputs connected, and after the with clause ends, it will close the Excel file and save it. Here, we again call toExcel with our data frame, but the difference is we're feeding in the writer object or the writer pointer instead of feeding in the file name itself. If you need to write multiple things into Excel, then Excel writer with the context manager is the way to go. If we look at pd.readExcel, output.xlsx, we can see that again we went back to our first case and the writer simply perform the same duties as toExcel. The main power of Excel Writer comes when you want to write multiple sheets in one go. Because you've opened output.xlsx as writer, i.e. you've created a connection with a local Excel file using Excel Writer as your context manager, you can write to it repeatedly and specify different sheet names. And it will allow you to see the different sheets that you have written. So here I'm calling toExcel once with sheet name equals sheet 1. And then again, I'm calling another times with the sheet name equals sheet 2. In N17, we're checking our work. We call read Excel, looking at outputs.xlsx again. And we can now see that we can have two sheets written in one call, sheet 1 and sheet 2. So that's out 17. In a slightly different example, in Excel, we can use the keyword argument indexed equals to false. And when we read the Excel back, we can see that the row 1 and row 2 index labels are no longer present. Instead, we have 0 and 1 instead, denoting the row numbers in the Excel sheet. Let's look at the last example. Here, instead of using the default settings, in the Pandas data frame to Excel, what I've done is use the start call keyword argument, which allows us to specify the starting column that we start writing in. This is very handy if you have a large Excel spreadsheet and you just want to modify a particular small area of it using your data frame. Again, if we check our work and use read Excel, we can see that in sheet 1 now, we see the following. We still see sheet 1, and we still see our data intact. But you can see that now there's an extra column on the left that is empty. Here it is represented by the NaN, not a number, that represents that there's no value in this column. And you can see from this row, the header row, that the column names are actually shifted one cell to the right. And that's what start column does. So that's out 29. In N30, I have a slightly different example for you. Here, instead of using start column 1, we say start row 1. So this performs a very similar, if not equivalent function as start call. So instead of start call, we do start row, and allows us to start one row down or 2 rows down, however many rows down. And what happens here is with pd.readExcel, if we read back what we've done here in 2Excel, we can again see that our sheet 1 is intact. However, the first row is unnamed, and only in the second row and the third row that we see our data.